Hey there, data enthusiasts! Welcome back to our channel. If you're passionate about data science, machine learning, or just curious about how artificial intelligence makes decisions, you're in the right place. Today, we're diving into a fascinating topic that's crucial for evaluating machine learning models, the confusion matrix. So, grab your notebooks and let's get started. Now, you might be wondering, what exactly is a confusion matrix, and why should we care about it? Well, let's break it down. At its core, a confusion matrix is a table that allows us to visualize the performance of a supervised machine learning algorithm. It provides a summary of the correct and incorrect predictions made by the model compared to the actual outcomes. Now, let's take a closer look at how this works. A confusion matrix typically consists of four key components: true positives, true negatives, false positives, and false negatives. True positives are cases where the model correctly predicted the positive class. True negatives are cases where the model correctly predicted the negative class. False positives, also known as type 1 errors, occur when the model incorrectly predicted a positive class when it was actually negative. False negatives, or type 2 errors, happen when the model incorrectly predicted a negative class when it was actually positive. To make it clearer, let's use an example from the medical field. Imagine we're building a model to predict whether a patient has a certain disease based on various health indicators. If our model predicts that a patient has the disease and they actually do, that's a true positive. If it predicts that a patient does not have the disease and they indeed do not, that's a true negative. If it predicts that a patient has the disease but they don't, that's a false positive. Lastly, if it predicts that a patient does not have the disease but they actually do, that's a false negative. Now, if we were to compile the results of our model into a confusion matrix, it could look something like this. This simple table gives us a lot of information at a glance. But how do we actually use this matrix? Well, it helps us calculate several important metrics that can guide our understanding of the model's performance. Some of these metrics include 1. Accuracy. This measures the overall correctness of the model and is calculated as. It gives us a general idea of how well our model is doing. 2. Precision. This metric tells us how many of the predicted positive instances were actually positive. It's calculated as TP. High precision indicates a low false positive rate. 3. Recall. This indicates how many of the actual positive instances were correctly predicted. It's calculated as TP. High recall means the model is good at capturing positive instances. For F1 score, this is the harmonic mean of precision and recall, providing a balance between the two. It's particularly useful when you need a single metric to gauge performance in imbalanced datasets. Now, let's consider a hypothetical scenario. Suppose our confusion matrix from the disease prediction model looks like this. Using this matrix, we can calculate the following. Accuracy equals 170, 200 is equal to 0.85 or 85%. Precision 80 equals 80 or 90 almost equals 0.89 or 89%. Recall 80 equals 80 for 100 is equal to 0.8 or 80%. F1 score 2 asterisk equals 2 asterisk almost equal to 0.8 for or 84%. These metrics help us understand where our model excels and where it might need improvement. So, to wrap it all up, a confusion matrix is an essential tool for evaluating the performance of classification models. By understanding the different components and metrics derived from it, we can make informed decisions about how to improve our models and better predict outcomes. If you found this video helpful, don't forget to give it a thumbs up and subscribe to our channel for more insightful content on data science and machine learning. Also, share your thoughts in the comments below. Have you used confusion matrices in your projects? We'd love to hear your experiences. Thanks for watching, and see you next time for more data-driven insights.